Good morning. Today I will share with you some of my recent findings regarding Oxytocin modulates attention-related intrinsic network interaction. Firstly, I will introduce a bit of background. Oxytocin is a neuropeptide that plays a crucial role in childbirth and breastfeeding. During the 1980s, the animal models had shown that oxytocin is also important for mammals' maintain emotional behaviors and social bonds. In recent years, studies began to examine the effects of oxytocin, giving oxytocin to humans through a nasal spray. It was found that oxytocin produced widespread effects of human behavior, suggesting potential therapeutic application of mental disorders. Behavioral studies have found that oxytocin not only promotes pro-social behaviors, but also increased antisocial behaviors, including violence and envy. That is the effects of oxytocin vary across social contexts rather than being always positive. In Gestalt study, they found that after oxytocin treatment, people pay more attention on eye regions of the faces. The eye regions include more social information. In addition, oxytocin effects vary as the individual differences, including the traits such as the traits and gender. A study from our lab found that the effects of early attention processing of social stimuli differ between males and females. Another study from our lab shows that oxytocin effects on early attention blink for faces dependent on autistic traits. Oxytocin produced stronger effects in healthy subjects with higher autistic traits. So based on these findings, we aim to examine answer two questions. First, does oxytocin already influence attention during the task-free state? Second, are the effects dependent on sex or autistic traits? The task studies found that the dorsal attention network, Salience network, and default network, triple network system are strongly involved in attention. The dorsal attention network contributes to goal-directed top-down external attention. The Salience network plays an important role in stimulus-guided bottom-up external attention, and the default network contributes to stimulus-independent internal attention. The default network generally presents anti-correlation with the dorsal attention network and the Salience network. And the great intrinsic anti-correlation between default network and the Salience network, dorsal attention network predicts better attentional controllability. So in this study, we aimed to examine modulatory effects of oxytocin on intrinsic interactions of the dorsal attention network, Salience network, and default network, particularly between internal versus external attention system. And we aimed to examine the influence of sex and autistic traits on the oxytocin effects. In a double-blind, placebo-controlled and between subject experiments, 187 healthy subjects self-administered either a single dose of 40 IU placebo or oxytocin. After 45 minutes after treatment, 8.5 minutes closed eyes resting state was performed. And then we extracted the brain networks using group ICA. We focused on 6 networks, the dorsal attention network, 2 subsystems of Salience network, and 3 subsystems of default network. Next, we calculated the functional network connectivity. This is the between network connectivity within the between network connectivity for each group, the placebo group and Oxytocin group, as well as the group differences. We found that Oxytocin increased the connectivity between the dorsal attention network and the Salience network. And we found the Oxytocin increased the connectivity between the subsystems within the Salience network, and increased the connectivity between the subsystems within the default network. These results suggest that Oxytocin increased the in functional integration within the internal attention system and within the external attention systems. And the figure B showed that Oxytocin increased the anti-correlation between the dorsal attention network and the default network, as well as Oxytocin increased the anti-correlation between default network and the Salience network. These results suggest that Oxytocin increased the anti-correlation between external attention system and the internal attention system. Finally, we examined the modulatory effects of individual factors on the Oxytocin effects, including the sex and autistic traits. We didn't find the sex differences in Oxytocin effects. However, we observed an association between the autistic traits and the connectivity between default network and Salience network. That is Oxytocin effects on Salience network and default network connectivity vary as a factor of autistic traits. In summary, Oxytocin modulates the intrinsic logistical networks, particularly the competitive interactions of the default network with the Salience network and the dorsal attention network. These network level effects are in line with the properties of Oxytocin system. Firstly, there are millions of Oxytocin receptors that's widely distributed in human brain. And secondly, the Oxytocin has a long half-life after release and release from all parts of the neuron. Particularly, the interactions of the PVDN with other components show the Oxytocin effects. Based on the previous findings, the PVDN component overlaps with the network involved in social cognition. So, therefore, the effects of Oxytocin may specifically involved in the social related attention, but not non-social related attention. Together, this global pattern may reflect that highly integrated cortical networks exhibit stronger intrinsic coupling, while integration between anti-correlated networks increased following Oxytocin treatment. These results suggest that the effects of Oxytocin on social attention and Salience may be gated by effects on the associated large-scale architectures. Thanks. The preprint of paper will be available soon at the archive. Thanks to my lab and thanks for your attention.